So before moving forward, I would like to give a brief discussion on the agenda we have planned for you. So first, I would like to give a brief understanding of why the agents have become a hot topic nowadays and what's the what has changed. I mean, and also then we want to discuss what role that agent can place in the domain of integrations. After that, we will give a brief introduction to our Ballerina AI agent module, and then we will show a demonstration on how the agent works in action. And also, if the time permits, we will discuss some of the limitations of AI agents. So this is the agenda we have planned for today. Yeah. So first, before moving to discuss the rise of the intelligent agents, I want to give you a brief understanding of what is an agent or what's an agent. So this is a program or a system interacting with the environment, and its sole purpose is to achieve a set of specific goals. Most probably, these goals are set by a human, or it can be also another entity. And these agents will perform certain actions on the environment, and based on these actions they will get some observations or some experience, and based on this experience and observation the agent will decide what are the next set of actions that they want to perform. And because of that, the agents usually simulate some aspects of human intelligence, and this can be a simple rule based system, or also it can be a very complex autonomous intelligence system like the self driving cars. Yeah, so what has changed? So we have seen a large boom in large language models, and because of these new capabilities that we have introduced to large language models, we have seen like they are very capable of understanding and reasoning in natural language. So because of this capability, what LLMs now can uh, do is they can basically, given a set of tasks or given a set of available possible tools, they can basically determine what are the actions that they can perform on top of those tools to achieve the given task. So this characterization available LLM as a brain to the agent. So that's what actually happening. So because of that, now what we can do is we can use LLMs and uh, couple them with a set of tools. These tools can be different functions, different APIs. This can be anything. Like so, these we can couple them with these tools and show them what are the available tools and say uh, we give a certain questions, or the user gives a certain question, and let them figure out what's the execution plan and what should they do to achieve the task at hand. So they will do the reasoning and basically figure it out. So this is the basic capability that have enabled building this autonomous agent rapidly. So to just to give a understanding how much innovation happening in this area, so I have this illustration from a survey paper. So these are the publication number of publications that has happened within past 2 years. So we can see a significant increment in those publications, right? So there are a lot of tools now being published and being introduced. All these tools are around these LLM based agents. Yeah. So we know that LLM have enabled building agents, but what's the importance of these two integrations? So let's discuss that now. So if we look at an integration, what do we have in a program that we have written to communicate with different APIs to achieve a certain task. So when we are developing an integration, what we have to do is first we have to decide what are the APIs that we are going to call and what would be the orchestration for those uh, communication to happen. And also we have to decide how we are going to talk to each API, because different APIs have different languages, right? So that means like they are, some of the APIs may use JSON and they have a very specific schema. Some of the APIs may understand only XML and they have their specific schemas. So we have to translate between these APIs. So these things we have to write into the code, and then only the integration will be successful, because we are defining everything required to basically build that control flow and the communication between the APIs. Now, on the other hand, we discussed earlier the LLM based agents has now enabled handling tool selection and also execution order, and also they can decide which are the data that we have to send to each tool. So these things are possible with now LLM based agent. Only thing we have to do is give our objective as a user command and also show what are the available tools. So given this information, what we can say for a future integration. So in that case, so can we ask this question like create an age? So to do a integration, would it be like create an agent and then just point the available API resources as tool to that agent? Yeah. So this keeping this question in mind. Now let's go and see how our Ballerina AI agent module work. Yeah. So with Ballerina agent module, we define several concepts. So actually, these are not new concepts. Some of these concepts already available within this domain. So we first have a set of tools because agents need to use tools to interact with the environment. And also we have a set of LLM APIs. This is basically the brain for the agent. So agent has to reason and think what are he going to do for next, right? Then also we need a way to execute the agents as well. So in that case, we offer certain levels, I mean certain ways to execute the agent. And this is basically to give more convenient execution. We have different ways, and also to make it more flexible, we have other method we have defined to execute the agent. So I will go into depth each of these things. Right now, this is the brief introduction. So let's first look at the tools. So first tool type is the functions. So because function is the most primitive behavioral construct that we can have, because it can take an input and do some processing and do perform certain actions and then give us a output, right? So agent can understand functions. So we have to basically, so to register and function to the agent, what we have to do is we have to create this tool record in Ballerina. So this tool record will include a unique identifier for the name and also the description. So this description is very important because it describes the behavior of the function to the agent or the LLM. And also we have to define what are the parameters that are expected by this function, the input parameters, and we can define it as a JSON schema. And also then we have to basically point to that function. So that's the caller parameter. So this is the basic tool, and then after that we have another tool because we are mainly focused in integrations, which is the HTTP resource as a tool. So in this case, this is a little bit different from the function as a tool because we don't have a specific function here. Instead of that, we have a HTTP resource that has a path and that has a HTTP method. So that's why we have two new parameters here for path and the method. And also to define the inputs, we have two parameters for the path and query parameters. We are using the parameters variable, and also for the request body, we have the request body. So using this, we can this record we can define the HTTP resource specification for the agent. But the problem is this can be a little bit inconvenient when we have a lot of API resources to define all these things by manually. So that's why we have another cool feature here, which can basically look at your API documentation. That means in OpenAPI, this is the OpenAPI specification we are talking about because that's the standard documentation for REST APIs. So we can look at the OpenAPI specification and then extract the tools automatically out of that OpenAPI specification. So then these tools that we can directly use with the agent. So this is the actually the most convenient functionality. If you want to connect to APIs easily, we can just get their OpenAPI specification and let the agent figure out rest of the information. Yeah, but the other important aspect is some of these tools are not actually individual tools, they are a collection of tools. For example, for API, we can have multiple resources and we define each resource individually, but we have to indicate to the agent that these are not for multiple APIs, these are for a single API. And also they have shared behaviors, shared parameters, and also shared configurations. For example, we have a service toolkit defined for HTTP. So we have a toolkit defined for HTTP service. So this is a equivalent of the HTTP client in the Ballerina concept. Because with this HTTP service toolkit, what we can input to the this agent is the service URL for the service, also the client configurations. This can include this authentication or other client configuration, also the common headers, which is similar to the HTTP client. And apart from that, we also need to give the list of HTTP tools here. So with that, we can create a HTTP service toolkit, and that's the tool object that we can pass to the agent. When we create that, I will show you it in a bit later. Yeah. So we talk about the tools. Now let's talk a little bit about what are the LLM APIs. So what we have seen is there have been, I mean, there are a lot of LLMs that coming up, but all these LLM has certain common characteristic. The earlier of LLMs, they were completion LLMs because they supported the completion task given a prompt. So we call them as completion APIs. And then the next generation LLMs, they started supporting chat APIs. So that's why we call them as chat API LLMs. And then there's this new set of LLMs that inherently support function calling, where it can decide and reason and propose us a function to use. So this is where we have this defined the function calling API. So we have categorized all the LLMs under these three API categories, and also we have I mean defined certain LLMs under these categories. Like for OpenAI and Azure OpenAI, we have already implemented the LLM modules, but for rest of the LLM, these APIs can be extended. Yeah. So based on these different LLM API types, we can define different, and also the other capabilities, we can define different agent types as well. So right now we have implemented two agent types. They can be extended. So what we have right now is one agent is the React agent. So this is the one of the first papers that came up proposing this reason and act framework, and based on that we have come up with this React framework where we use the chat and the completion LLMs to reason and basically get the tools that we have to execute next. And then we have the function calling agent, which strictly use the function calling APIs, and with that also we can decide the tools that we have to execute. And all these agents follow the same interface, so they take the same parameters and also can be used with the same executors, but only the internal execution is the internal reasoning is different. Yeah. So for executing agent also, I said it's a very important thing because we can have the convenience or we can have the flexibility. So for have the highest convenience, we can use the agent run, which will get the query and execute the agent in the single without any human interaction or without any user interaction intervention. It will execute it and return the expected final answer and also the executed steps. Or we can use the agent iterator, which can iterate through all the steps, and which is like using a for each loop. So it's a iteration. Then we have the agent executor. This is slightly different because in this case we have divided the agent execution steps also into reason and act. So we have the highest flexibility here. I mean, one use case would be like once the agent reason, we can apply sort of logics to modify that reasoning that has happened, and also to validate that before executing the agent, executing the tool. So that can be useful for certain mission critical scenarios where we need a validation step before executing the agent. Yeah. So I talk a lot about the agent and what we have. So now I will show you how to write the agent program. So agent, and here we use only 5 steps. So what we are trying to do here is we have a OpenAPI specification, and using that we try to recognize the tools and then create the agent. So during the first step, we have extracted the tools using the OpenAPI specification. We have to give the path to the OpenAPI specification here. And once we extract the tools, we are creating a service toolkit, because I said for API, we have to create a toolkit, which will basically get the service URL, and also we can have the client configurations here. And and then we have to create the model, which is the brain for the agent. And using this model and the toolkit, we can create the agent. So here we have created a React agent, and then we just have to give the command or the user's query and then run the agent. Yeah. So in a nutshell, if we talk about this agent module, what we have is we have ways to define set of tools using different artifacts, right? Is in this site. And then also we have ways to define a set of LLM APIs or LLM models, and we already have predefined LLMs as well. So those will help the agent to reason. And then we have three methods to execute the agent, where we can balance between the convenience and also the flexibility. Yeah. So let's look at a demonstration. I think that would help you to understand it very well. So before going to the demonstration, I would like to give understanding on what we are trying to implement with this demonstration. So what we have here is we have two APIs now. One is the Gmail API and the other one is the Train API. The Train API can list available train schedules and also book a train if you based on the given destination and the starting point. And also we can ask other operation. I mean, we can perform other trains or train schedule related operations using the Train API. And with the Gmail API, we can only do one operation at the moment. We only send emails. So that's the only required tool for us in this scenario. And we use the OpenAI GPT 3.5 model for reasoning. And one of the important thing here is, okay, we can get different questions from the user asking to book me a train from this is my destination and this is where I want to be. And like those kind of questions we can get from the users. And then the agent service is responsible for figuring out which tool to execute and achieve these tasks. But to demonstrate these capabilities very well, so I am using function as a tool to implement the implement the tool for Gmail API, and using extracting tool out of OpenAPI specification to use register the train API. So I will show you it in the code, but that's my plan. So let's go to the code. So what we have at first is bunch of configurations that let's not worry about them at the moment. After that, we have defined certain constants that are required to specify the OpenAPI specification path and also the email address for our train agent service. And also we have a record that define the input schema for the service. So let's not worry about those stuff, because one of the important thing that we want to consider is this function, because this function define a send email tool, the behavior of that tool. So what we have here is we have used the Gmail client, Gmail connector, and we are using the sender email and this message request record from the Gmail client to basically define the email that we want to send. And we send that email and return the respond as a string. So that's this is a very basic thing. So we are only sending an email and returning the response. That's what we are doing here. But then we start to define the service. This is a background service, and we have initialized a function calling agent in this case. And after that, we start to initialize the rest of the. I mean, we have only declared that we haven't initialized it yet. Here we are starting to initialize the agent. So what we have first is the tool record that define the Gmail email sent tool. So we have given it a name and also a good description to explain what this tool is doing. And also we have pointed to the function. Now we are now starting to declare the input schema. This is the most important part here, because we have used some of the special capabilities we have. One thing is here for the sender email, instead of putting a variable here, we have put a constant, and we have substituted that constant value with this email address that I have defined first. Now, this is a very special thing, because in this case, we know the email address. We don't want agent or the LLM to interfere and basically decide that for us. So when there are such cases, we can use this constant variable value and basically substitute, I mean, add the value directly for that constant is in the schema. And then the advantages of this is, now this value will not change based on the agent's reasoning. So the accuracy will be, this will be guaranteed. And also the other advantage is, we don't pass this information to the LLM side. So if we have any PII, so some sensitive information, and we know what the information is, if you know how to connect them, so in those cases we can directly do those connections using these kind of constants. So the other thing is, now we are defining the message request record also as a schema here. So when you are defining that, so this is the object schema, because we have a record here, so it's object in JSON terms. And if you look at this record, we can see that there are a lot of fields here. But when you look at these fields, to send the email for this specific case, because we just want to send a confirmation mail to the users saying, okay, your train booking is completed. We have booked this train for you. That's the only thing we want to change. So we need only this to field, which define the recipient, and also the one of these field to define the body in the stream email, and also subject. So that's why we have only defined those three fields in the schema, because rest of the fields are not needed for this use case. And also the agent will not try to define those values. So that's a additional advantage, because sometimes these agents can become a little bit unpredictable also if you put a lot of fields, and if some of the fields are not actually needed for this case, then it's gonna be I mean a risk for that use case, right? So that can also happen. That's why we are restricted only for the fields that are required, and this is a advantage for us. And then after that, we have now defined the tool for the Gmail send operation, that tool. And after that, we start to define the train API tools. So for that, first we extract the tools, HTTP tools, using this train API specification. And then we also extract out the service URL from that result that we get, and we get the tools also here. And then we create the HTTP service toolkit for the train API. And here we have also add the auth configurations, because this is a secured endpoint. So we have to use this client ID and client secrets to basically authenticate to this API. So that's the advantage of having this service toolkit, because you can add these kind of information for all the API resources at once, like the service URL and the auth configurations, apply them at once, right? And then we create the model for the agent. And using these things, we can create the agent. Now here, we have included the model first, then we have included the tool, and then we have included the toolkit. We can, if we have more tools, we can just keep adding tools and it will work. So now we have initialized the service. After that, we have to define the execution path. So this is where we get actual user commands. So as I explained earlier, user input will include the user's command and also his email and the location. So this information will act as metadata. I will show you where. Yeah. So when we define this, first what we do is we say how, I mean, we look at the agent and say to run that agent, and then we extract the command out of that and assign that as the query for the agent. And also we define a context here. The context is very important for this case, because with the context, we can define this other metadata for the agent. So this metadata agent can refer whenever necessary. So for example, the users might say, book me a train to this place, and they may not give us the starting location, or they may not give us the time, or those information might be missing from their code. So but those things we can extract based on their context, also the email address for that user. because those things are already known based on his whether he's authenticated or whether he has a session, or with all these things we can get those information. So here we have extracted his location and also his email and added that as a context information, and also I have hard coded the time here. This is because I didn't want to get the system time because you guys are joining from different places, so I just want to show you uh, what how the time can be set and how it will basically refer to that. So we have set that to 7 p.m. and then after that we run the agent using this command, and then we extract out the answer from the agent. So when agent is once the agent run, so we get the execution steps and also the answer from the agent, so we get both. But here we are only using the answer and we send it back to the user. We don't want to look at this information, but those will be logged so we can see when the agent is executing. So I will run this program now. So I will bring this up. Let me remove the history. Yeah. So it's running now. So let's see what we can do now. I have a set of requests that I have prepared already, like a request. So in the first request, what we are trying to do is we try to check whether there are any trains available from Grove to Colombo. So it's just a retrieval. We just want to ask a question from the agent. So let's run this command and see what will happen. So if we quickly switch to the service terminal, so we can see it's working and it's thinking what it should do. So there is a one iteration happening and it's saying, okay, we should execute this tool. And these are the parameters for that tool. And based on the execution, we get the observations also here. And we can see that observation, then agent is basically finalizing the answer, and basically it's printing the answer also here because we have enabled the verbose. And also from our curl command side, we can see the answer has been received here, right? And this is not formatted well because we are using the terminal, but if we use a different for web UI or something, we can see the formatted answer. So let make it a bit more complex and ask this question. So here what we are trying to ask is, book me the next train to Gaul and send me the confirmation as well. So we are not telling it where to send the confirmation, etc. It has to basically figure that out. So let's see the agent execution also. Okay, start to execute. Sorry, from here, and then first is look at the available trains from Colombo to Gaul. I didn't specify I'm from Colombo, but that information is taken from the context because we say my location is Colombo, and it extract out all those required records, the train schedules, and from that it's gonna pick us a schedule based on our time. Okay, we said the time is 7 p.m. So the next train is at 8 p.m. So it has picked it up. Start time is 8 p.m. and then it's basically trying to book that train, right? And we are basically using the train schedule now ID from this information. So it's referring to this information and getting that ID. And after that, we get the observation. Yeah, the train books was successful, and this is the train that it has booked. And after that, now it has to confirm that. So for confirmation, it's trying to use the send email. So this is the the tool that we define as a function, and for that it gives the message request, and also we can see the body in HTML. So that has been defined as HTML text. So and then also send the email is defined properly because we have set it as a constant. And then we get the observation also. It say the email sending was successful. Then it say the final answer. So I have successfully booked the next train, and these are details. So this detail will come up with the request also. So it's a little bit messy here because we can't see the formatted answer, but it's here. So just to verify, I mean, let's look at the email also. Oh yeah, I have got the email. So this is 2 minutes ago. Yeah. So it has the information about the train booking and it's here. I think we have a little bit time. We can discuss the limitations of the AI agents as well, because this is a cool thing. I think we saw the capabilities of it and what it can do and how capable that is. But there are certain limitations also, and this is not just with Ballerina AI agents. This is in general. Uh, Agents has these kind of limitations. So one limitation is LLM has certain accuracy aspect, and it there are certain unpredictable behaviors of the LLM. So this can be a problem when we try to do these kind of integrations. So sometimes it can go. I mean, most of the time it will go correct, but there can be cases it can give you inaccurate reasoning also. And also there's a performance consideration, because now if we talk about LLMs, they right now they are becoming faster and faster, but we have seen that they are a bit slow compared to traditional other APIs. And also for the agents, you need a single LLM call for each iteration, because you are going to reason for each iteration. So that's the performance drawback in that consideration. So, and also we have certain cost implications, because we are doing an LLM call for each reasoning process, each reasoning iteration, and that will have certain cost associated with the usage of the LLM. And we have to now wait out and see how well this is can balance, or how economical using LLM based integrations compared to the traditional integration development, because in that case we will have only the development cost, but in this case we have to keep paying for the LLM to do the reasoning. And also there are certain security aspect like prompt injection. This is a relatively new thing, because people can inject different queries which may have certain commands that would make LLMs to give away sensitive information, or do execute certain restricted operations. So this is not something we can prevent 100% at the moment, but this can happen. And also there can be other security concerns, such as your sensitive data being shared with the LLM side, because we might use OpenAI APIs. In that case, we are sending our data to that OpenAI APIs. So there are some customers might feel that, okay, these are my sensitive PIIs, so we don't want the external APIs to look at them. So that can be a concern. Yeah, so we have agent in our one of the production feature as well. So this is in this WSO2 Curio, we call this feature as the API chat. So what this feature does is, once you deploy an API with WSO2 Curio, you can use this feature to test it out. And this feature, with you can just give natural language commands. You can just talk with your API. That's why we call it API chat. And then basically you don't even need to give the data values most of the time, because it will generate the data values randomly, and most sensible data values, actually not just random arbitrary values. They are sensible data values, and then test your APIs for you. So let's look at the demo as well. Yeah, in this case, we say to add a pet, rename it, and then delete it. So start to do that process. Yeah, it do a post and then put and then delete. It give us a summary of what it has done also. Then we say to basically delete all the sold pets. So sold means there is a status for the pets, whether they are available or whether they are sold. So right now we don't have any sold pets. So it's saying there are no sold pets. So we are asking it to add 3 sold pets. Then the API chat will add them for us, and we don't have to do anything else. We just generate the random data values and add them. And after adding the solve pets, we will say it to delete them again. So it's gonna find all the solve pets and then delete them. Yeah. So this is basically agents in action in one of our production features. Yeah. So if you want to discuss, I mean, find out more about the agents, I think you can refer to these documentations. We have the agent library documentation, and also we have some of the samples which illustrate how you can use different type of tools and different type of agents within to build your application. So we have few samples available for that also.
Hey, that was great presentation and wonderful demo. Thanks for sharing it. So you talked about limitations. It's still in progress, or this is final product?
Hi Deepak, thank you for your comments. Yeah, so these limitations, they are not a concern only for the Ballerina AI agents. So this is a evolving field. So this is not a finalized product or something like that, because uh, this field is still uncertain. We don't know where we will go, and we where we can go. What's the potential? All those stuff is still being figured out. And there are different type of agents coming up also. There are a lot of research happening. So we are not yet sure what we will end up with, but this is just the first step towards that. And also, as we have shown, we are using this in some of our production features as well. But one thing is, we have to act with caution, because we are working with LLMs here, and there is a accuracy aspect always, right? So that's why we are not saying yet to build production integrations directly. Instead of that, what we try to use this is to test out our deployed API, something like that. Because in that case, we don't have any critical operations happening. And also another use case that might be just retrieving information instead of doing critical operations. So those kind of precautions we have to take into consideration. We can't just apply this and let, I mean, there are certain applications like this train booking application we might be able to build, but there are also, we can't do all the operations. For some of the operations, there might require certain human validation also. Like there can have a step, we will ask the user, is this the operation that you want to do? So those kind of precautions we have to take into consideration when we use the agent library.
Makes sense. Yes. So if I'm building something based on this agent, and tomorrow, if the underlying LLM changes, do it is like a hard dependency on that. Am I right?
Yes.
Okay, perfect. Thank you.
Welcome.
Nadish, can you talk a bit about the extensibility of this? Like,
Yeah,
what do I,
so
what do I
yes.
mean by that is, being able to combine different tools, different OpenAPI specifications, and so on.
Yeah, so we can basically have I mean, you mean multiple tools or multiple open
Yeah,
APIs?
yeah. I mean, in that sense, this is quite powerful, right?
Yeah, yeah.
And also, I think other point is relating to the previous question. So we can still go with the production deployments with this, because this is concurrent safe. There's a lot of things that we have done to make sure that this is scalable, right?
Yeah.
So which is not the case for some other existing libraries such as LangChain. So this can run in production. So the problem becomes when you have hallucinations, which is not a part of the agent framework. I think that can be addressed by, basically having those intermediate human validation. I think that's what you're saying, right? So if you have that validation step, we can take it to the production, even for the mission critical applications. Is that statement true?
Yeah,
That's what
yeah.
we are basically saying.
Yes, so there should be a human in loop, because I mean, what that's what I think Deepak was also saying. So there's hard dependency on LLM. So the accuracy of LLM will determine the outcome most of the time. So because of that, we need some validation steps also. One option is to have the human in the loop, and basically let him say, okay, whether I am going to accept this action or not. And as you mentioned, yeah, this is a concurrently safe library. So even the tools that you are registering, they has to be concurrently safe. Otherwise, we don't let you register those tools. And we have ensured concurrence, the that constraint is ensured always, except for the okay, the everything except for the executors and the iterator and the run, everything else is concurrently safe. But the executor is related to a single query, because it's going to execute your single query for that agent, right? So that's not concurrency safe, that you can use within multiple threads, but you have to create an instance for that. That's how it is designed. This is basically, we have designed this keeping in mind that we are going to write services. So we have to basically separate it out, what should be the concurrency safe and what should be within the initializer, and then what should be in the resource function.
Yeah, thanks. It's a great presentation.
If that's all the questions we have for today, I think we can wrap up. But yeah, if you do have any more questions, you can always email us at contact@ballerina.io, or you can always reach us on our Discord server. I have included the links as well here for your reference. So yeah, thanks everyone for joining. And again, yeah, thanks also to Nadheesh for that great presentation.